So how can we automate data science lifecycle steps such as data pre-processing, model creation, feature engineering, as well as model deployment on cloud so that we can reduce the time to delivery of the associated product, save time and increase the efficiency of budding data scientists, as well as reduce human errors when writing the code for these different phases of data science lifecycle. Folks, Nitin here, and this is the AI University channel. In this video, I'm going to explain the steps to automate various data science lifecycle phases, including data pre-processing steps such as missing value imputation, changing data types, dividing data into training and test set automatically, automated model creation and fitting, model comparison, as well as model tuning. This can be a long video, but believe me, the information covered in this video will benefit you in a long run and will give you a competitive edge on the other data scientists. Since the demand of data scientists who not only knows developing these models manually, but also in an automated fashion is growing exponentially. So watch this video till the end. If you are new here, then consider subscribing to this channel, or if you have already subscribed, then click on the bell icon to receive the notifications about hottest technologies of 21st century. Please show your love and support by liking, sharing and subscribing to this video, as I will feel highly motivated. Also, we now have the AI University Android app and the website, which is in beta mode right now. You can download the code related Jupyter notebooks by enrolling to this course right here on the AI University website. All the courses are offered free on this website. You can access the related quizzes and certificate of course completion like this from the AI University. So let's move on. There are various open source and licensed libraries and frameworks that provide similar functionality. Some of them are AutoScaling, Teapot, whose full form is tree-based pipeline optimization tool, AutoVeka, AWS SageMaker, Google's AutoML, H2O, etc. So far, you may have been performing data pre-processing, exploratory data analysis, feature selection, model building, model training, generating predictions and deploying the model in production manually. But now you can automate all these steps by making use of a library known as Carrot. You as a data scientist will save a lot of time, thereby utilizing that saved time in drawing the insights from the models, building insight story using data visualization, etc. for stakeholders or end users. Major tech companies are looking for candidates who can not only build these machine learning models but also deploy them in production quickly to reduce the time to delivery. Let me now open the PyCarrot website to show you what all features it offers. So this is the PyCarrot website. Their motto is powerful solution, low code, which is absolutely true. If you click on getting started, you will get complete guide of PyCarrot along with steps to install it. It offers various other features like model training, model ensembling, model analysis and model deployment automation steps under the function area. Then you can find data preparation, feature engineering, feature selection capabilities of data pre-processing steps in under pre-processing tab. In the modules section, they have documented all the major supervised and unsupervised algorithms. Along with this, they have provided tutorials for both intermediate as well as beginner users. By engaging this library, you can automate the entire data science lifecycle. Now, if you are looking for only automating the exploratory data analysis steps of data science, keeping some flexibility to build the model for yourself, then you can watch this video where I have covered the explanation of automating the exploratory data analysis steps in just one line of code. So it offers variety of capabilities and you can explore all these features by visiting these individual links given here. So let's go to the Jupyter notebook and see the steps to install the library first before we explore other features of the machine learning automation. So you can use Google Colab Notebook if in case it looks more user friendly to you. I'm using Jupyter Notebook on my computer. So in the first cell you can see that we are installing the PyCaret library by using command exclamation mark followed by pip install PyCaret. It will take some time to get installed. You can run the same command without exclamation mark from the Anaconda prompt. If in case you are using Anaconda distribution and you prefer to install these libraries from the command line, so you can just type pip install PyCaret on Anaconda prompt and press enter to install this library. Let's move on to the next cell. Here we are importing necessary libraries including PyCaret. In the next cell we are using Titanic dataset to show you the PyCaret feature. Most of you might be already aware of this dataset, hence I have taken it for better clarity. You can take any other dataset as per your requirement. Using this dataset, we want to predict the survival of passengers, that is, if he or she has got survived during the Titanic accident, based on several other features like passenger class, gender, age, port of embarkation, etc. This is a classification problem as the outcome of the survival is binary. Either the passenger got survived or not. So survival is our target or dependent variable here, and rest others are the feature variables or independent variables. So in the next cell or this particular cell, we are reading this Titanic dataset using pandas read underscore CSV method and then creating a data frame named as df. You can also see that I have used df.head method or the head method to see the subset of rows from the data frame. Let's move on to the next cell where we are importing all the functions from the PyCaret.classification using star. And then after that we are setting up the environment for building and comparing various machine learning models. We are making use of this setup function here that takes arguments like dataset name, which in our case is Titanic dataset, and the second argument is the name of the target variable, which in our case is survived. There are several other arguments to this particular function, setup function, such as categorical features, remove multicollinearity, remove outliers, feature selection, etc. associated with it. And you can explore all those parameters on PyCaret website. So you can see on their website all the parameters listed down here inside setup function. So you can see numeric imputation here, date features, right, outlier, remove outliers, outlier threshold, remove multicollinearity, right, transformation, transformation method, categorical imputation, etc. So you can include as many arguments as you can inside this function as per your requirement. I'm using only 2 arguments here. So when you run the cell, it will start validating the data type of each column. And once it does pre-processing, it will ask for your input by providing a text box asking you if the data type looks okay to you. If it does and you are satisfied, then type yes or Y. If not, then you can type N or no and come back again after performing some manual pre-processing. It will show the data type of target variables as label along with other numeric and categorical variables. So let me rerun this cell and show you. So you could see that survived column has data type shown as label, and then we have several other columns whose data type is either marked as categorical or numerical. So let me type yes in the text box here, and you can see that it is still doing some processing. So as soon as you type yes, you will get a message at the top saying that setup successfully completed, followed by some other values here or kind of a report here. So as you can see here, it is kind of giving a report where it is telling you that target type is binary, which is true because survived column has value either 1, which suggests the passenger survived, or the value 0, which suggests that passenger didn't survive. Now the original data section tells the number of rows as aged 891 and columns as 12 in the data set. Then there is another information like numeric features are mentioned as 3. So there are 3 numerical features and 8 categorical features present in the data set. It has also automatically divided the data into training and test set, and parameters like transformed train set and transform test set suggest that only any missing values in the dataset features are imputed using mean. Okay, so you can see the numeric imputer is mentioned as mean here, and we have set the values for many of these parameters in the setup function, hence the report is showing false or none for most of the parameters. So you can see that one can perform PCA or principal component analysis, normalize the values, transform the values using this particular setup function, and everything will be done automatically. Then in the next cell we are comparing several classification models by using compare underscore models function. When I ran this cell, it fitted 14 classification models such as KNN, SVM, Logistic Regression, AUTOMATE, quadratic discriminant analysis, naive Bayes, etc. At the time of fitting this model, you will observe cross-validation values as well. And if you want to learn more in detail, including the theory and programmatic implementation of these algorithms, which are listed right here, then you can watch this playlist. Link is given in the I button above. Let me now rerun this cell. So you can see that in the status section, the continuous message fitting fold 10 of 10, 1 of 10, etc. is showcased, suggesting that the cross validation is being performed. It also shows you the model name in the estimator section here while doing this cross validation right here. So right now it is doing it for QDA. So once it completes the processing, it will show you all the models sorted, or all the 14 models sorted from the decreasing order of accuracy. You can see that it has not only fit these models but also evaluated them using various metrics like accuracy, area under curve, recall, precision, F1 score, etc. If you want to learn the theory and practical implementation of these evaluation or performance measuring techniques in detail, then you can find them in this playlist. Link is given in the description section. If you are wondering what is Kappa, then let me tell you that it is the metric that measures how closely the instances classified by the machine learning classifier matches the data labeled as ground truth. Kappa statistics for one model is directly comparable to the Kappa statistics for any other model used for the same classification tasks. You could see that extreme gradient boosting is giving us the highest accuracy of 82.2. Logistic regression is giving us the highest F1 score and Kappa value. Gradient boosting classifier is giving us the highest values for AUC or area under curve and precision. And naive Bayes is giving us the highest value for recall. So you can pick up your model based on the metric you are relying most. There might be data scientist who evaluate and finalizes his model based on precision, recall and F1 score. Other might just pick the model on the basis of highest accuracy. So that again depends on your requirement and analysis you have done. So let's move on to the next cell where we are creating one specific model according to the evaluation matrix. So as I mentioned earlier, we can pick any particular model based on the metric we prefer. So in my case, I am picking up this extreme gradient boosting classifier based on the accuracy, okay, because it is giving highest accuracy. That's why I'm picking up this particular classifier just for the example purpose. So in this cell, I'm creating the extreme gradient boost classifier. So we are using function create underscore model, which takes an argument, and that is the abbreviated name of the classifier to create a model. In our case, we are providing that argument value as XGBoost. We are naming this model as XB, short form of XGBoost. So we can get the complete list of abbreviated name of algorithm or classifier right here on the PyCaret website, as you can see here, right? So these are the parameter uh, and or the estimators, and these are the abbreviated values here right on their website. So when we ran the cell, it provided the various evaluation metric value at each of the 10 cross validations. Then at the last, it is showing you the mean and standard deviation values of all the metrics. Now let's go to the PyCaret website once again, and let's go to the function section, then model training, followed by last section called as tune models. So you can see that there is a tune_model function available to perform hyperparameter tuning, or in other words, finding the optimum value of model parameters so that you could get better accuracy and predictions with your model. Now in the next cell, we are tuning this model by making use of tune_model function, passing the name of the model, which is XGBoost, as an argument. We are naming this again as XB so that your original model gets replaced by the tuned model, and you can then use this tuned model for your predictions. Moving on, let's now see how do we do predictions using XGBoost model we have fitted here. So as you can see here in the next cell, we are creating a data frame from the CSV file. This file contains unseen data without the label column named as survived, because this is something that we want to predict. You could see the snapshot of it here, and you can see that there is no survived or target variable present. In the next cell, we are predicting whether the passenger mentioned in the unseen data frame would have been survived based on the features like gender, age, passenger class, cabin details, or from where he or she has embarked. We are using predict_model function to predict the Titanic survivors. This function takes arguments like model name and data frame containing unseen values. When we ran the cell, we got the output as shown here. You could see that two new columns, namely label and score, have been added. Label depicts the binary value where 1 represents that passenger survived and 0 represents the passenger didn't survive. Score depicts the probability score or strength of that prediction. In the next cell, I am showing you how to save the model for later use. We are using a function save model to save our XGBoost model. This function takes arguments such as model name and the text string with which we want to save this model. I want to save my model with the name xb_saved_062020, hence I gave it that name. Here 062020 is nothing but the date in YYYY format. When I ran the cell, I got the output message as transformation pipeline and model successfully saved, which means that my model is saved now. Now that we have saved this model, later you may need to load it for prediction purpose. So in the next cell, we are loading this model using load model function. We are passing the name with which we saved the model earlier. Hence, I passed xb saved 062020 as an argument. When I ran the cell, I got the output message as transformation pipeline and model successfully loaded, which means that my model is loaded and is ready to do predictions. Similarly, you can deploy the model on Azure Web Services using deploy model function that I will cover in the next video. So this is the way you can automate entire data science lifecycle for not only classification, regression and clustering models, but also for association rule, anomaly detection and natural language processing. You can explore the PyCaret documentation on their website in detail to understand various other features. I will also cover them in the later videos. So folks, this is it for this video. Hope you have learned something new today. So here is today's question. Choose the correct option. The number of classification models compared using compare model function are 13, 14 or 15. Please post your answers, comments in the comment section given below so that I can get a chance to incorporate your feedback. You can also post your technical questions in the comment section and I will try to answer the same. If you're watching this video and you're not already a subscriber to our channel, consider clicking that little subscribe button. In case you have already subscribed, then click on the bell icon to receive the notifications whenever I will release a new video. So thanks for hanging out with me, guys. I will be covering next topic in the upcoming video, so keep on watching. Thank you.